Today I'm going to quickly go through the quotient rule for differentiation. This is going to be very similar to the product rule, so I'm going to go a little bit more quickly because we should understand most of the details by now. As usual, we're going to pick one of our limits because this is comparing two functions. I'm going to go with the top version where the two variables approach each other because there's not a lot bought by going with the difference that we have in the bottom. We're going to apply this using a quotient of two functions and see what happens. I get the derivative of the quotient is equal to the limit of the quotient evaluated at x naught minus the quotient evaluated at x, all divided by the difference between x naught and x. The first thing I want to do is I want to get a common denominator, so I'm going to multiply the first fraction top and bottom by g of x, and the second fraction top and bottom by g of x naught, and that will give me a common denominator so that I can compare the numerator terms. As I do this, we'll notice that this looks very similar to what we had for the product rule in the numerator, and we're going to do a very similar thing where we create some space. And we notice now that rather than having both x naughts on one side, we have two separate terms, each with its own x naught, so that the terms we insert can just have the x's. And these are arranged mostly so that I can separate them out. The first expression, the first two terms can isolate, we can factor out a g of x, and the second two terms we can factor out an f of x. And then I also factored out the denominator. Notice in that first one, it looks like we could cancel the g of x over g of x, but we want to keep that around so we can recombine the fractions later. I also get f naught minus f of x over x naught minus x. That's going to turn into our derivative for f of x. When I factored out the f of x from the last two terms, I also factored out a minus sign with it, so that minus f of x g of x naught turns into a positive g of x naught, and the positive f of x g of x turns into a minus g of x. So we get minus f of x over that same denominator, and followed by the derivative of g of x. When I evaluate the limits, the only indeterminates come from the derivatives, and those will just turn into the derivatives. So when I evaluate the limits, I get unaltered g of x times the derivative of f of x minus unaltered f of x times the derivative of g of x, and all of that divided by g of x squared. And that is going to be our quotient rule for differentiation.